So I'm Jay. I'm here to talk to you about Legend State and how to build local first apps using any backend. So who here has built local first apps before? Raise your hand. Okay. And how many of you rolled your own sync system? All right. All right. So first, a bit about me. I make Legend, which is a local first productivity app, combines documents, calendars, and a built-in browser. Some of our users have millions of items that need to be filtered and sorted as they type. So performance and sync are really critical for this. I'm also working on Bravely, which is a platform for mental health therapists to run their practice and collaborate with clients. Healthcare data has really intense security and privacy requirements, so it needs to work really reliably in poor network conditions as well. So we cannot ever lose any data. So doing local first well is essential for us. So normally when you build a local first app, it means managing three different things. You've got your local app state, you've got your data from the server, you have some kind of a sync engine in the middle somewhere. Sometimes that's its own server. Sometimes you have a bunch of client-side logic. But in Legend State, the state just syncs itself. So let's talk about how that works. So the core primitive is an observable. Some people call this signals with hierarchy or deep signals, something like that. So you can create observables from any data structure. It can be an object, an array, primitives, whatever. You'll see I use a $ suffix on stuff. That's just a convention, just to know that it's an observable. So the API is pretty simple. You just get and to read, set to write. There's no immutables because they're slow. There's no actions or reducers. It's just direct manipulation. And it works for infinite levels of nesting. So as you navigate through an object, it creates a proxy dynamically for each child. And this doesn't modify the data at all. It just wraps it in a proxy to add some functions for change tracking. So in React, we have a useSelector hook, which tracks the observable and re-renders when it changes. And so this is a key difference from using useState or other state libraries. The useSelector tracks only the data it accesses. So you could give it an observable directly, you could give it a function that accesses observables, and it'll just re-render itself when those change. So in this example, when email changes, this component doesn't care, so nothing happens. But if the name changes, then it'll re-render because it cares about the name. So this granular tracking is really good for performance. But even better for performance is for the component to just not re-render at all. So we have this little memo component that you give that an observable or a function, and it'll re-render itself when stuff changes. And that's just the tiniest little thing. We can also just two-way bind stuff. So we can bind the name directly to an input, and then the observable will be updated as you type, but nothing has to re-render except for the input. So what this looks like in practice, there's little flashing boxes every time we have a re-render. Normally in React, you set state at the top. It just passes all the way down, rendering everything on the way. Whereas on the right, using the observable signals method, only the count has to change, so you get these tiny little updates for that. So this, along with lots of other optimizations, is what makes it significantly faster than every other React state library and vanilla React itself. But this is not the Performance First conference, so I'm focusing more on how this enables a sync engine. If you do want to talk about performance, let's chat later. So because an observable node is a proxy that doesn't touch the raw data, it could actually point to anything. So it could be one of the children of your object, but it could also be a function. So we have this name function here. If you access that as an observable, it just treats it as a computed observable. We could also just create a totally new object. So if you have a child that takes a string parameter, it becomes a lookup table. So you can access usernames by ID, and those actually just two-way pass through to the original observable. So if you set username's ID, it will set the name on the original user. And this works well because the computers are lazy. So as you navigate through that lookup table, it creates the proxies dynamically. And that laziness allows something pretty interesting, which is The observable could point at a promise. And since it's lazy, it doesn't do anything until you get it. And that triggers the fetch, returns undefined, and then updates itself when it resolves. So if we use that in a component, it'll first render empty, and this would actually crash. Oh no, has the or, yeah. So this will render empty, and then once the fetch finishes, it'll re-render with all the messages. But fetching is a bit complicated, so we have a little fetch helper for that. But then that can also track the changes. So if I just set on this observable, then it sees that it changed and it can send it back to the server. So now this state is two-way bound to the server. And so that's where it gets interesting for local first apps, because when something changes, we don't just know that something changed. We know exactly what changed, where in the object, and how it changed. So every change we get includes the path in the object that changed, as well as the previous and new values. So this fine-grained changes is what makes it perfect for a sync engine. So with all of that information, we can make a little sync engine here. So we have this synced helper, which basically connects the observable up to a sync engine. So when you access the profile, it will go and get it from the server, then it'll cache it to local storage. And then if you refresh the page, it immediately has it from local storage. And whenever you modify the profile, it'll send it to the server. So one way that you can make a sync engine is on the set, you get the array of changes. You could send that to the server, let the server figure out how to deal with the changes. Or we have a bunch of plugins. So we have this CRUD plugin. You just give it all of your CRUD functions. So you give it list, create, update, delete. It figures out which item changed. So in this example here, I'm adding message ID. So it'll see that that did not previously exist. That's a create. So it'll send the create to the server. If that did previously exist, it would see which fields changed and then just send the diff to the server. And then if we add a bunch more options to this plugin, there's a retry sync on the persist, which will, if you make a change while you're offline, it'll save that change and it'll just stay there until it syncs successfully. So then once you eventually come back online, it'll finish syncing. This can also just retry syncing while you're online indefinitely until it succeeds. We have a partial sync. So if you see this top line here, we get the newest updated at timestamp on all the items when we load. So then we can get from the server only the things that have changed since then. So we can get really small diffs syncing back and forth. And so that saves a huge amount of processing time because you don't have to process the whole object, and also saves you on bandwidth. So the key to making this retrying work is, since we know what fields are changing, we can save that to the persistence. So if you modify the user's name and email, we'll track exactly that those two fields changed. And they'll stay persisted until they sync successfully. So basically the way the sync stuff works is when we restart the app and come back online, we receive the remote data, we rebase our changes on top of that, and then if anything is still changed, it'll just flow through the sync system as usual. And so you can have large observable stores if you want, so you can mix synced stuff along with just regular non-synced things. Or you can have just individual atoms if you want, kind of up to you. And since all the sync data is observables, we get all the nice properties of them, like the computed values. So I can just have an unread count on the messages that comes from the server. So whenever the server data changes, the unread count changes automatically. And we also have helpers for all the loading state. If you want to show spinners and stuff, we can get whether it's loaded from persistence yet, because some persistence is asynchronous, like async storage on React Native, and like what the state is of the sync. And if you want to do local first well, you probably want to have real time in there. So there's this subscribe parameter that gives you a refresh and update. So depending on how your real-time system works, Like in Firebase, it'll just give you real-time values, so you can just update those directly. Sometimes you might just get a little notification that you should update, and you could do a refresh. And that basically works with however you want to do it. You could also just poll every 5 seconds and just do a refresh. And so because the sync engine is in the state, it doesn't actually care what your backend looks like. So we have built-in plugins for some of the more popular sync systems. So we have Supabase, Firebase, Keel, React. There's a React query plugin if you want to just use that. Or you can build your own plugin on top of CRUD. It also doesn't even have to be a server. So you could bind directly to the brightness on your phone. And so you could bind a slider just to that. It'll load it immediately, and then whenever you move the slider, it sends it to the brightness API. And since the sync system lives in the state, you can kind of enhance your sync engine over time. So you can start out with just basic prototypey fake demo code, and then you could add persistence to cache it to local storage. Then you could set it up to sync with Supabase. And then if you don't like Supabase, you want to switch to a different provider, you want to make your own, then just change it. Your app code doesn't care. It's just in the observable itself. I've actually done this myself. I switched from Firebase to a Postgres-based system and just didn't have to change any of the front-end code. So wrapping up this little intro here, I think Legend State's interesting because it gives you the best possible performance you can get in React. And it's a very powerful back-end agnostic sync engine with, I think, pretty simple developer experience. So that's my little intro. I assume there's going to be some questions. So get into some questions if anybody has any. Otherwise, I'll just show a bunch of code and stuff. Yeah? Sorry, can you speak up a little bit? There's a standard that's still in process, which I'm not using. I have my own implementation for it. Yeah. Yes.
I wonder, is there some way to conflict that for the sync part?
So I believe somewhat strongly that conflicts are not actually as big of a deal as people think they are. So generally, just say, let the server handle it. So if the client has changes that it thinks should be sent, send it to the server. The server can throw them away or do whatever it wants. But that being said, I am planning to add a way to do that client side. A way I do it in my other apps is just duplicate an item. So if you happen to be editing the same thing, just duplicate it, and then you can say, oh, I don't want that one, just use the other one. But we could potentially have a CRDT plugin or something to be able to do that. This is just kind of like the primitive layer outside of it. But in, I think most apps, you're not actually editing the same text box as other people, so it's not a huge problem. Yeah.
So I think you had a kind of a long table example. Kind of a virtualized table or a really long table. If I couldn't see it correctly.
That does sound like something I would do.
So I'm just wondering, how do you deal with pagination or filtered data? This type of.
I don't think I'm going to find that.
You know what I mean?
Yeah. So I also have another library called Legend List, which is a good way to do lists on React Native, and eventually I'll get to web as well. But for pagination, a way I deal with that on the sync side is to have an observable page number, and then the query can just get the value of that and add that to the query params. And then because the query is reactive as well, whenever you change the observables that it listens to, it'll rerun the query, and then it'll merge the results into what you have already. Yeah. So as you scroll down, you just increase that page observable, and that will go and trigger a query. Yeah. Anyone else? No? All right. So I'm not going to do the code along thing because we don't have that much time. So I'll just show you some code. So I have this little to-do app here, which I'm going to show you. So basically, I have my own to-dos. I'll just make that app bigger. Yeah. And then I can go and add a to-do, all good. I also have a list of users from a previous workshop. So I can click on those users and see all their stuff. And so then if I turn off Wi-Fi and then refresh this app, oh, that's just, okay. So if I refresh the app, I'm offline, I still have all that stuff. I think, which user did I press? Is it this one? No. That's the one. So I still have that because I looked at it before. And so I can go and make another to-do. And so then if I refresh, then I make another, did I type rod? Jeez. So that's still there because I was editing that offline. And then I'll eventually connect. It'll sync, everything's fine. So yeah, let's look at how this works. So I have, everything is done in this state file. So the way this works is first I set up a persistence plugin. So we're going to use async storage in React Native. And then I have my user observable, which is only persists to storage. That doesn't actually sync anywhere. And then there's this when helper in legend state, which basically, when the parameter becomes truthy, it'll run the callback or a promise. So once it's loaded from persistence, it checks to see if I have an ID or not. If I don't, it generates me one. So then I have my device as a local ID. And so then I'm using the Keel plugin, which is a Postgres-based database. And so I just can configure it with some default props here. So I can set it up with the async storage, set it up to retry all that stuff I was showing you before. It has a thing where it can require authentication, but just disable that for now. But it does wait until I have an ID before it'll start syncing. And then it just refreshes every 5 seconds to pretend we have real time. Excuse me. So then I have this store, which is my entire state system here. So the users, it gets, remember how this works. Yeah, so it gets the updated at, which is the newest timestamp from all of the data that I have already. So it'll get me only the users that are updated after that. And then there's a lookup table per user ID, which gets all the to-dos for that user. So that similarly gets all the to-dos that are after that timestamp that equal this user. And then we have all those CRUD functions for that. And then we have some computeds where that will basically get the whole thing sorted so that we can display it nicely. So then as those to-dos sync from the server, those computeds just rerun themselves automatically. And so then the to-do list just gets the to-dos sorted, computed, which comes from the server, and just maps that onto an array. And then that item, it gives it the actual observable, not the to-do object, because it can use that observable to just listen to specific things. So we have these reactive helpers for React Native, and there's also web versions of this too. But we can basically two-way bind the text onto this input. So as I type into the input, nothing re-renders at all, it's just that input is changing. And then we can bind the checkbox to the completed, and then the delete button just deletes it. So this is all just kind of operating on the local state that we have here, but that also just flows through the whole sync engine. How are we doing? Any questions at this point? All right. Throw up a hand at any point if nothing is making sense. So let's see, then there's also the new to-do. So that one, we generate an ID locally and then assign that into the to-do, which is kind of deep in this user object, which the sync engine sees and then sees that it's a new thing, and then it adds it to the server. So that's the whole thing, basically, for this app. So yeah, this little thing right here basically set up the entire sync engine. So, all right. So this could work with any other backend. I think this was originally a Superbase demo that I changed to use Keel instead. But I could very easily just change this to-dos to sync to Superbase instead. And then that would just work. The front end doesn't care. Yes?
So if you use updates one to do, how does that map to like React queries now like?
So React query would be, let's say, a slower way to do it. So what this would do is, if you update the text of one to do, then the synced CRUD system sees which to do it was that changed, and so it will go and fire off the mutation for that one thing. So there's not like a query cache that you have to invalidate. It just knows what changed and needs to be updated. And then, whereas query would re-render the outer component where the query is every time, this does not do that. It would see that the text changed, and so it would render just that text element on all the other devices. Yes?
So I have a scenario when I want to go into like an edit mode.
Yes.
And modify, and also be able to cancel that edit.
Yeah.
Is this easy to do here?
It is. We have a helper called useDraft, but effectively what it does is it takes the one that you're syncing and just clones the object, and then you work on that one, and then when you save, it just sets that into the synced one.
Nice.
Yeah. Yes.
So in this demo, I saw that you pretty much weren't using any default React hooks.
Yes.
Does this replace them entirely, or is there situations where you might still need to use, for example, a use effect, or can that also just be accomplished with observables?
Most things can be accomplished without the React hooks. There's still some situations, mostly if you have data that comes from somewhere else that's not observables. But yeah, we have, so there's a use mount, which is effectively use effects with empty depths. And then you would use observable instead of making a use state. Use reducer is just crazy. So this would replace that as well. There's also that thing in strict mode where it runs twice. So we have use mount once. We'll just only run once. But yeah, basically stop using use effect, stop using use state, and just use this instead, yeah. So I'll show you another app that I'm working on, which is this app for managing GitHub issues. So this is all of the issues on my other list library. This is all the issues on Legend State. And then if I go offline and close it and open it again, I still have all that because I cached it. This is still in progress, so I don't have saving yet, but just an example of that. But so main container. Is this how much I want to zoom in? That looks good? Yeah. So basically, the way this works is we have all the GitHub issues in this observable store here. And so I'm accessing that by repo name and then the issues child under it. So I have multiple repos that I can use. So basically the way that works is I made a synced GitHub plugin. And so when this is that lookup table thing, I get the issue by repo. And then the URL in the GitHub API is this. I have a pagination observable for that. And then I pick the fields that I want because the GitHub API is really verbose. So I don't want to cache all that. So I just pick the ones I want and then transform it. So the way this works is this sync to GitHub plugin takes the params that I want and converts them into the GitHub API's params. So they have page and per page. And then there's a transform option in the synced. So I can do that pick and then return just the things that it picked out. And then I have this wait for. If you're requiring auth, it waits until you have an auth token for it. Otherwise, it can just get the public data. And then this type is either a get or a list. And then that will take the last sync date to only get the diffs of the recent stuff. And then it fetches it from GitHub. And then it persists this using Expo file system. So I made a persistence plugin for this. So Expo file system, I guess I left out a detail. This is a React Native macOS app. So I can use Expo modules, some of them, in here. So basically what this does is I can create a file for each of the API requests and then parse that. And I have two different ways I can do that. One is with JSON, one is with Message Packer, which saves it as a much smaller binary format. So it'll unpack it with the bytes. And then, or is it the save file just does the opposite. It just packs it and then writes it. So then, now that I have this persistence plugin there, this just creates these files and caches it whenever I use it. So I did some performance testing on this, and it was kind of interesting. It seemed like the fastest way to cache all of my GitHub issues is just save them as message packer files, not using SQLite or any of the fancier things. I think once I get into search, I might need to go that way, but for now, it just uses the files. This basically saves a file for all of the issues per repo, and then a file for all the details of each issue. So there's just a bunch of files saved there. So yeah, that's kind of a weird example of I can two-way bind to a server that I do not own because it's GitHub. That's the nice thing about doing everything client-side is I don't need to own the server. I can just hook up to it. Yeah. Any more questions? Yes.
Related to this draft mode again.
Yeah.
How about if I do like 100 changes?
Yes.
It need 100 updates, and I click save, or can I patch
So
them?
it basically it saves all the fields that you changed. So if you change the same field a bunch of times, it'll just overwrite it.
Yeah, but if I do it to 100 different items,
Yeah.
It's 100 updates.
Yeah.
Okay.
Yeah. And so depending on how you set up your sync plugin, that may send 100 different row updates, but you could potentially have a way to batch them into one. Yes.
Yeah, but the problems when the first node is too big. So your example, the should not be a problem, but if you want to load more data at first.
All the observables are lazily loaded, so it'll only load the ones from persistence that you actually access on the first screen. So it'll avoid, like, when I open this app, it won't load the other repos. It'll only load what I need here. So that helps a little bit. But then, yeah, the just general performance problem of trying not to load too much stuff at once. So you could potentially put some things in a delayed load so that they load from persistence later. And then also there's pretty wide variance in the different persistence layers. Like when I was testing this, I think using SQLite, it was like 25 milliseconds to load. And then using the Expo file system /next using Message Packer, it's less than 1 millisecond. So it's pretty wide range. So if you're going to be loading a lot of stuff from persistence, you need to pick your persistence system pretty carefully. So we have plugins in Legend State on React Native for async storage, MMKV, and SQLite. And then on web, there's just local storage and IndexedDB. But then if you're making an Electron app, you could save it through Electron to files somehow. And then I'm probably going to add this to the repo, the Expo file system one. I just did this like last week, but I'll add that too. So I'm trying to have as many persistence and sync plugins as possible. But I think for a lot of the different local first backends that are out there, I think we can plug Legend State's reactivity system just on top of that and just make them faster on the front end. So you could just not even use our sync engine part of it and just hook up the reactivity part of it. Yeah. It was kind of a crazy project to do both the fastest front end and also a sync engine, but here we are.
What specs in mind for what are you developing towards?
So this is currently on beta 30 of version 3. So I'm trying to just stabilize everything. But then the next is I just want to add a lot more plugins for different backends and more persistence systems. And then the debugging is kind of hard. So I want to try to figure out how to improve that. Because basically the problem is when you modify an observable, it tells React that it needs to re-render. And so then in a microtask, React re-renders. And then you don't have any stack going back to the thing that caused that. And so I need to figure out some way to make that debugging experience better. I was just looking at the live store debugger tools this morning. Those are pretty nice. So I might make some way to view the state of all the observables in process, something like that. So that's probably the next thing. I'd also like to support more frameworks because the observable stuff is very generic. So we could support Solid and Svelte and whatever. I just started with React because it's what I know. Yes?
How it's more take Solid work? Will you like native like signals from Solid, like the entire thing could be?
So Dev and I were talking about this earlier. So I think they have a new store system in Solid, which we could potentially just plug into. But we'll have to figure out more details of that. But it would be very cool to be able to use Solid stores with Legend State sync engine. But basically we just need that deep signal hierarchy and also what changed at what level to be able to do the sync engine. Yeah. I think there's potential also for hooking up SQL. Like you could potentially have an observable that looks at a SQL query and is responsive to the results of the SQL query. So I might play with that, see what we can do there. But since it can basically, any child of an observable can point at anything, I think there's all sorts of stuff we can do. Yeah. Yes?
There's potentially, because of UG lines in browser,
Yeah.
you can use contributor points and get notifications of when individual rows change.
Yes.
It triggers, potentially does that, the other thing potentially does that.
Yes. Yes. Yes, I think we should do that. That sounds awesome. Yeah. I don't know where to start with that, but that is certainly feasible. We should do it. Yeah. Does anybody want to talk about anything else? We can talk about performance if you want. Yeah.
Is there anything that is coming from JavaScript and you expect that will help you improve performance?
I don't know. There's the signals thing, which is still in discussion. I don't know if we can actually use that though, because we need the deep hierarchical stuff. And then my other interest is in virtualized lists. And there's some talk of, I actually don't know the state of it. There's like a proposal for a web version of virtualization that's built in. But I'm not sure where that is. Yeah. Oh, did it? I don't know. I've been so focused on the React Native side of it for the past 6 months. I don't know.
I'm curious, are there situations where you would advise against using this?
I think if you're doing something that just doesn't ever change, then there's no reason to. But for general React apps, I think this is the fastest way to build React apps is this way. Because you skip so much of the work that React does.
What are there downsides to that?
I don't think so. Yeah, I haven't found one yet. There might be. Who knows? Yes.
Yeah, so I just wanted to maybe use a stupid question, but this pretty much replaces any reason why you want to do server-side rendering or anything like that, because this solves the sort of performance issues that come with loading stuff from the server, because it's all local, the observability is fast, so there's no reason to use any of these kind of Next.js modern React rendering paradigms.
I'm not going to say there's no reason, but I'm a big fan of client-side rendering, personally. So this is the paradigm I always use, is do everything client-side. But I think there's valuable benefits from server-side rendering. Like, for example, one of the problems you'll get with this pattern is people could be using an old version of your app, and you change stuff on the server that the old version of the client doesn't have. That's actually a thing we could talk about. But basically, the migration is potentially problematic. And so if the server component just brings you the new everything, then you could potentially just dynamically update your app from server components as you're in process. I don't think I've seen anybody doing that yet, but I talked to people about it in the React Native context. So you could, basically dynamically update pieces of your app from the server while it's running. So there's some cool stuff there, potentially. Yeah. Other topics, which are not fully solved yet, is the conflict resolution piece. So I think we discussed that a bit already. So the migration, the way that we do that is you can have a transform on both the persistent side and the sync side. And so basically the way you would do server migrations is when a new version of your client comes out, you'll load from persistence, and you can put in your persistence data like a version number or something. And so then when your new client loads the old persisted data, you could say like, oh, that's version 1, I need to change that into this other format, into how the app sees it now. Another way to do that is just if you have old fields, be like, oh, I see you have old field, change that to new field. But yeah, if you have potentially a user who comes online for the first time after a year, then you have really old data on a new version of the app, and you need to have some way to deal with that. So this is what this transform does. You could potentially just say, return undefined, it's too old, fuck off. I don't know what to do with you. But we don't want users to ever lose data, so don't do that. And then these are all the persistence layers we have right now, which I talked about a bit. So we could look at how you would do this normally in regular React is we have use optimistic. And so the way that I understand this to work is that when you are sending new data to the server, you first create a local copy, and you're using that local copy, and then you save it to the server, and then when that succeeds, you replace your local copy with the server copy. I still find this really confusing. There's a lot of code, a lot of 2 different states I have to manage. It doesn't, and so then this I copied from the React Query website. So I think this is how you do optimistic mutations. So my understanding of this, which is very small because I had to shrink it. So you first have to cancel any queries that are currently running, and then snapshot the current value that you have, overwrite the internal query cache with the optimistic value, keep the previous value in case of failure, and then manually invalidate the queries after you get it. I just find all that very verbose and very confusing. So then the legend state version of that is just, it's a lot smaller and easier, I think. So I personally don't like having the sync system as part of the component because one, it makes the components longer and slower, and then every time you get a query coming back or you do a mutation, it renders that component. And one of the apps I'm working on for a consulting thing. We're not using legend state, so I have to deal with React Query. And there's just a big problem of like, the query reruns and then an entire table re-renders, and it's really slow. And I've tried to get them to switch, but they're not in a phase of the project where they want to switch state systems. But I've had to make so many crazy workarounds for just the basic React things, like it renders the whole table. So yeah, basically the legend state way of doing that is the data comes into an observable, which you then consume wherever you need to and re-render. Well, I think that's all I got. I guess we're done a little early.